contrast the conic sections that we've done thus far. So, why is there so much arguing? Okay, somebody give me a real-world example of a parabola.
A headband.
A headband.
No, the one you wear when you're like 3.
But that kind of curves more like that, because that would be more like this, right? Horseshoe? Same thing. Trajectory. Ooh, I heard it. Dot, 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 dot. Shooting something up in the air, throwing a ball, right? Yeah. Exactly. It's a parabola. That was good. Circle. Real life. A ball? Okay.
More than a sphere?
No, a wheel. Pretty much anything. Wheel. A
A
coin.
pizza?
How about a 2D ball? What? I can't.
Beach ball. Beach ball.
There we go. Thank you.
Beach ball.
Beach ball. Okay. Ellipse.
The way the earth revolves around the sun.
Okay, so here's the Earth. An elliptical path around, right?
Yeah.
Okay. All right, you guys are getting way too excited. Okay, hyperbola. Oh, nuclear reactor. Not bad. Okay. That's a good question. Okay, so I want you to show me on your whiteboard. Let's see how fast we can do this, guys. I want you to show me on your whiteboard the general equation horizontally for a parabola. Should we do vertically first?
Yeah.
Let's do vertically first. Show me what a vertical parabola looks like.
Okay, how do you make that fast?
Vertical? Is this vertical? Think about yours. Vertical. That's horizontal. Yeah.
I mean, I can't write.
What?
No.
Oh, get another one. Okay.
All of them are donuts.
So it should be, vertical should be, guys, 5, 4, 3, 2, 1. Vertical should be y equals a times x minus h squared plus k. So show me what horizontal would look like. Good. Good, good, good. Good. What's the main difference? X equals, what's the other difference? H and K and switch. Good. Awesome. X minus K squared plus H. What about the focal length? Awesome. 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 Wait. Oh, I'm sorry. You're right. Somebody caught it. This should be Y. Okay. I see it. Fantastic. Okay, 1 over 4A, or a fourth of A, right? Okay, circle. Show me the vertical circle. Yeah, that's a trick question, right? Circles are circles are circles, right? Good. 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 But they would have to be the same in order for it to be a circle. But that's not the circle. Good. That's too much for me to read, even though I'm very happy about all of that. Good. All right, guys. I'm recording 5, 4, 3. 3, 2, 1. So a circle it's still recording. I never stopped it. I'm going to go ahead and just draw myself a little line there because it's just x minus h squared plus x minus k y minus k squared equals r squared. Good. And the focal length? No. Think about it. What would the focal length be? Why would I call it a focal length? The radius. Exactly. It's not really a focal length, right? Your radius is serving as your focal point. Your focal length. The radius that you're measuring from the center out to the outside of the circle, correct? You don't need to know all these fancy formulas. Think about what it means, right? Okay, an ellipse. Show me a horizontal ellipse. Okay, so this one horizontally, right, would mean that we have x minus h squared. We have a y minus k squared. It equals 1. There's a, what kind of sign? An addition sign. And if it's horizontal, that means that A is associated with X and B is associated with Y. So what's the difference about vertical? Switch the A and B. So X minus H squared over B squared plus Y minus K squared over A squared equals 1. What's the focal length of an ellipse? What do we use to measure that focal length? Minus B squared. So what are all these right here? Pretty much, Rena says pretty much the same, except for what? What is the difference? We're comparing and contrasting. So this one is adding, kind of like the, like the branches are going towards each other, being added together, right? And with the hyperbola, it's like the branches are being subtracted or going away from each other, right? So this is just x minus h squared, y minus k squared. This is now a negative sign. But where is A? Right here. It's always there. Why is it always there? Why is the bigger one always going to be in front? That way you don't get a negative, right? The bigger one always has to be in front. Are you listening? You said you're confused and then you're not paying attention. Okay, so the reason why is when we have something that's vertical, you have to switch the numerator, if you think about it, because A, the bigger one, the transverse axis, has to be in front because we've got a subtraction sign here. Does that make sense? The bigger one has to be in front because there's subtraction. Why is the bigger one not in front here? Because it's addition, and addition is commutative. Make sense? Thank you. Okay, so this is now a subtraction sign, and it becomes x minus h squared over b squared equals 1. And the focal length? It's added. Good. Now that you see it all on one page, is it all really that hard? It's a lot, but is it hard? It's not really that hard if you visualize it. That's why we keep putting these graphs on there, because if you get a picture of what it's supposed to look like, the other pieces just kind of fall apart, right? Or I shouldn't say fall apart, they fall into line, correct? Questions on this so far? I'll post it. Give me a second, I have an explanation. Pausing. 1, I will be able to solve solve, we're really going to solve, right? Look at that, double solve. Double solve systems of inequalities involving conics. I'll be able to explain to our partner how to identify a conic. All right, I'm going to pass out your work. All right, solve the system of inequalities by graphing. So I purposely don't want to teach you how to pull these apart. We're going to go pretty quick on this because we've been doing that all along, right? So this is basically a review lesson with inequality signs. All right, so these are the questions to ask yourself. What type of conic is it? What type of conic is this one? That is just a line. Good, who said it? Thank you, Sam. That is just a line. So how could I change that to standard form? I'm sorry, here's our second one. I didn't write that down. How could you change it to look like something that I could graph, Sam? Subtract x. So I would get y is less than negative x plus 4. Does everybody agree? You guys are scaring me. Does everybody agree? Okay. Should we graph it now before we talk about the other one? Okay, let's graph it now. Put it in pink. All right, so how do I graph this? We start with the y-intercept, which is at positive 4. So we go up 1, 2, 3, 4. And where do we move? We begin with b. Remember that? Y equals mx plus b. And then we move down 1 over 1 or up 1 and then the negative direction 1. Up 1, negative. Up 1. I always go up in positive or negative. Okay, we need ourselves a line that matches the same color. Pink. 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 Okay, who can tell me what's wrong with my graph? Other than it's not perfect.
Oh, it should be dotted.
It's supposed to be dotted. Good. Remember that? And we need to shade it for it as well, correct? Let's shade. So I'm going to shade what? Am I going to shade below the line or above the line?
Below.
Good. Do you guys remember my analogy for that?
The cloud?
The clouds. If you're standing on the line, are the clouds below the line or above the line? They're below the line.
Oh, wait, I'm thinking of something. Like if you're standing above looking up the clouds, and if you're looking down and looking at the clouds, being reflected in like a puddle.
Oh, I like that. Sam, we talked about, my mom used to live up in the mountains, and sometimes early morning I would come driving down the mountains, and so I'd be going down the mountain, right? And sometimes the clouds would be below me. And that was always so cool. It's like you're driving to heaven, right? Okay. Okay. Oh, true, right? Okay. All right, what is the next one right here? What's this one? Think, think, think. Think, think, think. Everybody think. Okay, you guys pay attention up here. 5, 4, 3, 2, 1. When everybody just yells something out, do you know what happens? Nobody can think. So I want you to think silently about what it is and why. What components do you see that give you evidence of what type of conic that is? Let's think back, like, for at least, give everybody a chance to think for a second. Okay, go ahead.
It's a hyperbola because it's a negative and there's a y squared and x squared.
Okay, there's a y squared and there's an x squared, right? So, and there's a negative sign, so that means it's a hyperbola. I wanted to change my color. Green. So it's a hyperbola with a y, not a u. A hyperbola, and what's the orientation of it? Or vertical? Why is it vertical?
Because the y is first.
Because the y is first, or the y is positive and the x is negative, right? Okay, so what do we need to do to manipulate this inequality so that we could graph it? Divide everybody by 64. So when I divide by 64, I get y squared over what? 16 divided by 64. What's this denominator going to be after the 16 cancels? Good. Minus x squared over, what's going to happen when that 4 cancels? Good, you've been doing your homework. Is less than or equal to what? 1. Fantastic. All right, so I'm going to start, where is my center? 0, 0. How far am I going to go up on the y? 2. How far am I going to go on the x? 1, 2, 3, 4. 1, 2, 3, 4. I'm going to get up and do this. Is that right? What am I doing? It's on the ellipse. Do you know what chimed me in on why I did that wrong? Because we already, listen, this was a good learning experience. I already told myself it's supposed to look like this. Then I drew it like that and went, wait a second, why is it horizontal? Oh, because it's not an ellipse. It's a hyperbola. I did that on purpose. Okay. Somehow I don't think you guys believe me. All right. That's all right. Okay. Okay, now I'm going to make myself a box. A dotted box, because it's not actually part of the graph, it's just guiding the graph, right? And what else does the box need? The asymptotes, so they should be, they have arrows on them because they're actually lines, right? Which kind of gets a little bit confusing. Maybe we should make everything that's not part of the graph black. What do you think? Yeah, you guys need like colored pencils. I'm learning something here. Okay, I'll make the hyperbolas red, yeah? Or black? Black? Yeah. Okay, so now we know it's supposed to look like this, right? So I don't even need any other pieces of information right now, correct? It didn't ask me what the foci are, correct? We're just graphing, straight graphing. This is kind of a really good review, right? So, since I know it's supposed to look like this, I just use these here to draw my branches. Devin, ask me again. Because y squared came first. We're working off of the y-axis right now. Make sense? If the y comes first and we're oriented around the y, that means my branches are going to be coming off the y. Make sense? Okay. I'm not done. I need to shade it. Look at, I lucked out. It's less than or equal to. So I have solid lines. Okay, how could I shade it? I'm going to test a point. What point would you test, Jesus?
0, 0.
0, 0. Let's see if 0, 0 is part how would I say that, is a solution. A Cx00 is a solution to my graph. So if I put in 0, 0, I would get 0 minus 0 is less than 64. Is 0 less than 64?
Yes.
Yes, it is. So therefore, that's a solution. Jesus is going to fight me forever on that one. So, okay, why am I stopping here? Can you guys see it? Is that clear? The solution to an inequality, a system of inequalities, is where the two graphs intertwine. So, this right here, that's why it's really important to shade. This one might have been easier to shade the hyperbola first, and then do the line. Well, you guys see this though? The shading, our solutions are anything that's squished in between these two branches right here. Anything that's squished, but there's a limitation on it because it's not the only thing that we're talking about. We're also talking about this line right here. I'm recording, so I can give you some. We're talking about that, and my solution involves everything that's below that. So I know I can't go above that line right there. That's where it goes. See it a little bit better now? I can't, as I'm shading, and I shade here, right? Shading, shading, shading. Oh, there's a boundary right here. I can't go past there because my solutions are anything that's below that pink line.
Wait, but then why did you shade that other one?
Where?
It's not. I think it's a green, right?
It's just green. Just where the green is.
So just like the middle part. That's the answer. That's the answer.
The solution. You guys want a different color?
It's all like a borderline.
I think it's more confusing. Guys, if I bring the green, I understand that you guys are talking it out with each other, but I need, when I'm talking, I need to come back to me, okay? So I get it. I know that my green should go all the way across here, and maybe I should do that, but we already have a really busy graph right now, correct? So, you want me to try it and see what happens? The green should go all the way across, right? But then, where my solution is everything where pink and green are both happening. So here is the green and the pink both happening here. Is this helping? See it now? Make sense?
Is this that green line or the parabola?
The hyperbola.
Hyperbola.
The green line, that's why the green line is dashed. Because the green line has, I shouldn't say nothing to our graph, it's guiding the graph. It's not actually the graph. It's the line, it's like, it's our guides on how to draw it. Okay? So I need to go, actually that would just be shaded right there, right? So I'm shading everything where there's pink and green. That better? Just go all the way across with the green, even though it's really messy. I don't know how else it's going to get prettier than that. Okay? Let's do another one. Yes. Okay, there's not that many. See? May I go? So let's go back and ask our questions again to ourselves. What type of conic is it? We recognize that. What are the different components I need to graph this? What were the different components? Guys, I'm talking again. What are the different components I need to graph it? Somebody tell me by raising their hand. What things did we consider? Jesus? Okay, but how did we get there? He's right. We considered how they both intersected, right? Yes. Okay, that's really detailed. I wasn't looking for that much detail. I was looking for the fact that we needed to figure out whether it was a solid or a dotted line, right? We had to figure out if the shading was above or below or inside or outside, correct? Can you think of anything else that were big keys of what we had to remember? Okay, let's move on. Let's do number 6. The other ones, number 1, 2, and that was number 3, right?
Yeah.
1 and 2 are easy, 4 and 5 are easy. Let's do 6. Okay, without saying anything, just look at these two and see if you can tell me what type of conics these are just by looking at it. 5, 4, 3, 2, 1, recording. This one, the circle. The coefficients, you guys, actually an ellipse and a circle have the same formula, right? But the coefficients are the same of the circle, therefore it doesn't expand, right? An ellipse is a circle with the same x and y have the same coefficients. Okay. So what's the difference? See how this one, when you divide, so I've got to complete the square on both of these, right? Which I should be able to do pretty quickly. So x squared plus 4x plus what? Plus 4. If I add 4, what else do I have to do? Subtract 4. There's the first part. Everybody follow me? Mm-hmm. You've been doing your homework. You should be able to do this pretty quickly. Let's do the y part. Plus, do that here. We don't have enough time. Plus, I'm going to do this one in green. Y squared plus 2y plus what? Plus 1, and then we have to minus 1 is less than 11. Okay, I'm going to do it in black now. So what's this one? X plus 2 squared, and what's this one? Y plus 1 squared, and where does the -4 and the -1 go? How do you get them there? And so 11 plus 5 is?
16.
No, if you don't have to divide, right? Because if you divided both by 16, right, then the major axis and the minor axis are both 4, and if they're both 4, it's a circle. See how they're both related, the ellipse and the circle? So since they're both the same, you don't do that step, right? You just leave the 16 there. It's the same thing, exactly. You leave that there and just go, I know I have a radius of 4. Interesting, huh? See when you put it all together, how things just unfold like that? Okay, so I have my circle is at what? What's the center of my circle? -2, -1, and the radius is 2, 3, 4. We're running out of time, huh? I timed that one perfectly. So I got you on your way on this, right? Then you need to test the point. Then you got to find the intersection. Do you think this is doable?
Yeah. Yes, but not for a quiz on Friday.
No, yes, but not for a quiz on Friday. I will take that into consideration, Jacob. Thank you.